Elon Musk is a really cool guy, but he's also extremely important for working on some of the world's hardest problems. I mean, think where we would be with electric cars. We may still be believing the myth that they had to be slow. Or how about going to Mars, or even living there? That may not even be a question. Now, what if we had another Elon Musk working on world hunger? How about the inequality gap, the housing crisis? The thing is, there's too many problems that we haven't solved. It's just that we don't have enough people working on important problems. I mean, Naveed and Nadeem know what I'm talking about. But I think one main reason of this is that people don't actually have the information needed to tackle these problems. But when we look at things like our Explore, they're just YouTube videos. YouTube videos everyone has access to. In fact, 1.9 billion people have access to these videos. That's reaching people in third world countries, giving them the ideas they need to make an impact. So why isn't it happening? Well, YouTube is structured more for watch time rather than information. They're there to keep you on the site longer so they can make more revenue off of ads. Let's take an example of what you may see in your feed, an informational video and a non-informational video. And if we look at the stats on these videos, we can see the informational video has been around for a year but has 4 times less than the uninformational video. So what I'm trying to do is filter out these unproductive videos and label these videos as productive or unproductive using natural language processing, or NLP. NLP is something as simple as Siri. It's all about understanding your text and speech data. And just to give you an idea of how much text and speech data we have, if you cut up the Amazon rainforest, all 390 million trees, and wrote on a piece of paper back and front for all those trees, and multiply that by 1,000, and then multiply that by another 1,000, you would get a zettabyte. And if you multiply that zettabyte by 20, that's how much information you have access to on the internet. But we're not using this information, and it's because computers, they can't understand it. So to solve this, what I specifically decided to do was go into a field called sentiment analysis to tackle this problem. I didn't exactly do it, but what it revolves around is taking something like a sentence and predicting if it's positive or negative based off some of the words in that sentence. But instead of doing something positive or negative, I wanted to read it as productive or unproductive. The steps for this project were getting some data, which, because this was a unique project and nobody's worked on it before, I had to gather 1,000 lines of YouTube titles and label all of them. But it was worth the wait. Next was pre-processing, which is crucial for the computer to actually understand the text. The model, which was able to find patterns in the data and then make predictions if it was productive or unproductive. To break down pre-processing, let's look at something your grandma would type in the Google search engine. Who was the winner of America's Got Talent 2019 with a question mark? Versus what you may type in, like AGT 2019 winner. The changes in this are quite similar to pre-processing. The first step is tokenization, where we split up all the words into individual tokens. It's kind of like if you take a Kit Kat bar and break it up into each individual piece, because it's easier to eat, just like it's easier for our computer to understand the words. The next step was removing uppercases. It's easy to keep the data nice and clean and all alike, and this way the model doesn't find specific changes in the data. This is what my data looked like before and after these first 2 steps. You can see all of it was converted to lowercase and they're split up through commas. The third step of pre-processing is removing common stop words. Words like of, the, and they're not really important for the computer to understand. They just help our speech flow better. So by reducing these common stop words, we can also reduce the size of our data set. But we still have a main problem, and that's that computers and words do not work well at all. So we need a way to represent words as numbers. And I did this using Glove. Glove is essentially trained on the entire Wikipedia data set and creates dimensions to map relations between words. A dimension could be something like, does it have 4 feet, or is it sports related? Is it an animal? And you could have 50 of these dimensions. And then depending how closely the word is related to that dimension, then you can match the difference and predict what words are related to each other. But even after turning all these words into numbers, we still have two main problems. And that's that computers can't understand context and things like sarcasm. And they also can't understand sequential order. These two sentences are inputted to the model exactly the same. So it may not understand something like a double negative. So to fix this, I tackled this problem in the model using a long short-term memory model, also known as a LSTM. LSTMs are lined up in cells. So let's break down one specific cell. If we look at one cell, it has the cell state, which runs across all these LSTM cells, and the data that's passed forward to each one. We then have the forget gate. If something's not important or doesn't have enough information, then it will just be forgotten. For example, something like a double negative, whatever comes after will be positive, so it's not important for our neural network to understand that. And then we also have the input gate, which is the new input in this case. We add it in, and then we also add it to the cell state. And this is a loop that's constantly going on in how we're able to retain information from previous cells and remember sequential order. And finally, we have the output gate, which may say this word is productive or it's unproductive. That's essentially what I did, but what really gets me excited about this is taking something like positive and negative to productive and unproductive. What about if we could do it with something like, is it fake or real in the news? Or how about if something's informational or non-informational? We could sort all this out and get knowledge bombs every day and remove all the fluff in places like articles. But this is, of course, just one field of NLP. There's so much more. There's things like chatbots. An example is a company called Casper, which has a chatbot on from 11 p.m. to 2 a.m. to help people with insomnia get to sleep. But the thing that excites me the most is question answering. IBM Watson recently won a game of Jeopardy. And I think if AI and humans ever want to work together, we need to understand and speak the same language. And we're going to do this with NLP. But question answering is still being developed a lot, and it may be present when you give rage quits to Siri. So I think the real implementation here is being able to work together with AI, which is necessary for our future. And because this field is still being developed, you have a chance to impact it. And now you can do that with YouTube and source out all the productive videos. Thank you.